Welcome to this explainer. You know, when you picture the heart of Rome, you probably imagine a bustling, modern European capital just absolutely woven through with ancient ruins. And usually those ruins are safely cordoned off behind ropes, right? They're these marvels of the past that we kind of just look at from a distance. But today, we're looking at something entirely different. We are exploring the Pons Fabricius. It's Rome's oldest surviving bridge that still stands in its completely original form. I mean, this is a structure that has witnessed empires rise, invasions sweep through, earthquakes shake the ground, and literally countless floods rage down the river. Yet, it is exactly where it was put. So we're going to break down exactly how this absolute engineering marvel managed to conquer time itself.
Okay, let's dive into this. 2,000. More than 2,000 years. That isn't just some historical footnote, you guys. It's a mind-bending, everyday reality. Built way back in 62 BC, this structure hasn't just sat idly by behind glass in a museum. No, it has been continuously serving pedestrians, day in and day out, for over 20 centuries. I really want you to think about that for a second. The exact same stones that Roman citizens walked across during the days of the Republic, those are the very stones that modern commuters hustle across today on their way to work. It literally bridges the gap between the ancient world and our modern lives.
In our modern world, we're honestly incredibly used to, well, fleeting infrastructure. I mean, a road gets paved and 10 years later it's a field of potholes that takes the city 6 months to fix? A modern bridge gets built and it requires constant, massive overhauls just to remain safe? We live in this era of very temporary builds. But when you look at Roman stonemasonry, you are looking at incredible, unchanging permanence. The stones right beneath the feet of pedestrians in Rome today completely defy our modern expectations of wear and tear. It's almost an arrogant display of endurance by ancient builders when you compare it to what we build today.
Which brings us to the central mystery of this explainer. How on earth did a bridge built in 62 BC outlast an entire empire? How does a structure simply made of rock survive constant exposure to the elements, gravity, and the rushing waters of the Tiber River, while the seemingly invincible Roman Empire itself completely collapsed around it? It's just a massive, fascinating puzzle. And to solve it, we really need to understand the environment that demanded its creation in the first place.
So let's jump back in time for a minute to Rome in 62 BC to look at the Republic's massive expansion.
Back then, Rome wasn't just a city, it was rapidly expanding into one of the most powerful and complex civilizations the world had literally ever seen. You had this massive explosion of trade, a booming population, highly active politics. The city was practically bursting at the seams. It desperately needed reliable infrastructure to connect its thriving districts and support the frantic daily life of its citizens. Now, at the time, one incredibly strategic location was a small landmass right in the middle of the Tiber River known as Tiber Island. It was a completely vital crossing point. To improve access and properly connect these crucial districts, Roman authorities knew a basic wooden bridge just wouldn't cut it anymore. So they commissioned a grand new stone bridge. And this monumental task was entrusted to a guy named Pons Fabricius. He was a Roman official whose entire job was overseeing roads and public works. And honestly, because he executed this project so flawlessly, his name was literally carved into history. The bridge would forever bear his name, Pons Fabricius.
Now, what's really interesting about this next part is looking at the actual engineering secret behind all this. How exactly was this thing built to last?
Okay, so we know who built it and why, but the how is where the Roman building genius truly shines. I mean, Roman engineers were undeniably among the greatest builders in human history, and Pons Fabricius is perhaps one of their purest masterclasses in civil engineering. The bridge spans a full 62 meters. That's over 200 feet across this rushing river. And they didn't just use any random rock, they sourced these massive blocks of highly durable volcanic tuff and traditional Roman stone. The core structure relies on two large primary arches, supported by a huge central pier. But wait, here is the absolute stroke of genius. That central pier includes a smaller, secondary arch right in the dead center of it. Why? Well, it's a flood relief arch. During periods of really heavy rain and high water, instead of the river just slamming into a solid wall of stone and pushing the bridge over, the water flows right through that smaller opening. It massively reduces the pressure on the entire structure. It's such a simple, elegant, and extraordinarily effective design that has saved this bridge time and time again.
So the crucial point here is really understanding the physics at play. It all comes down to the arch. Roman builders deeply, deeply understood the power of this shape. Think about it. If you build a flat bridge, the weight presses straight down, basically fighting gravity, which creates weak points right in the center. But a curved arch? It takes all that heavy downward weight from the stone and the people walking on it, and it gracefully redirects it outward and downward into the sturdy piers at the base. It doesn't fight gravity at all. It completely embraces it to create this exceptional, almost unbreakable stability. Let's walk through the deliberate, incredibly precise steps these engineers took, because it's fascinating. Step 1. Selecting that super weather-resistant volcanic stone, knowing it had to face the elements essentially forever. Step 2, and this one is mind-blowing. They carefully fitted these massive stone blocks together perfectly. Many of these stones remain exactly in place today, relying on the sheer friction and weight of the arch design rather than any sort of modern chemical mortar. No cement holding it all together. And step 3, designing absolutely every single element, like that flood arch we just talked about, specifically for longevity against the constant, relentless flow of the Tiber River.
So how did it actually hold up over the centuries? Let's take a step back and really look at how this structure managed to completely defy time.
I really want us to reflect on the immense scale of time we are talking about here. The Roman Empire, for all its absolute might, eventually fractured and fell. So many of its legendary roads, its sprawling aqueducts, and its other grand bridges slowly crumbled away and disappeared into the fog of history. Yet Pons Fabricius stood firm. Let's move through this timeline and see how this builds. Starting in the year 62 BC with its original creation, the bridge successfully carried ancient Romans. Then, as we move forward, it survived the dark, chaotic centuries of the Middle Ages. It stood strong and saw continued, daily use through the cultural rebirth of the Renaissance. And now, here in the modern era, over 20 centuries later, it is still standing. And sure, while minor repairs and routine maintenance were naturally performed over these thousands of years, this bridge, unlike so many other ancient structures, was never completely rebuilt. It brilliantly retains its original Roman design and its original foundations. That literally makes it one of the most authentic surviving examples of Roman civil engineering anywhere on Earth.
But to fully appreciate this bridge, we have to look at where it actually takes you. Tiber Island. And this introduces a beautiful legacy of healing to our story. You see, the bridge links the main city of Rome directly to Tiber Island. And this adds such a deeply vital human element to our story of just, rocks and arches. This island wasn't just a random piece of land in the river. It held a very specific, cherished place in the hearts of the Roman people, and the bridge was the physical pathway to get there. And this brilliantly illustrates one of the most fascinating cultural continuities in the entire world. In the ancient era, Romans strongly associated Tiber Island with medicine. They built these grand temples there dedicated to health and recovery. Well, fast forward to the modern era, and what is on the island today? Working hospitals. They are continuing that exact same medical tradition. So crossing Pons Fabricius wasn't just a daily commute. For generations of Romans, both ancient and modern, crossing this bridge meant entering a place of hope, healing, and community. The cultural purpose of the destination has remained remarkably unbroken.
This brings our narrative fully back to the present day, to what is essentially a living piece of history, the modern commute.
One of the most absolutely astonishing facts about the Pons Fabricius is that it is not preserved under glass. It is wonderfully, chaotically alive. Every single day, locals rush across it carrying their groceries, and tourists wander across it snapping photos. Very, very few structures on Earth can claim such profound continuity. It's so much more than an archaeological monument. It is a living, breathing piece of history. When you step onto it, you are sharing a physical experience with people who lived over 2 millennia ago. Every single step across its surface truly is a journey through time, because you're feeling the exact same solid stone beneath your feet that a Roman citizen felt in 62 BC.
So, to wrap up our explainer today, I really want you to consider this. Pons Fabricius isn't the largest bridge ever built. It certainly isn't the tallest, but it is a massive testament to ingenuity, craftsmanship, and a vision that literally transcends centuries. It is, quite simply, a bridge not just across a river, but across history itself. It leaves you in absolute awe of Roman engineering, right? And it begs a really fascinating question. What, if anything, that we build today will still be serving its original purpose 2,000 years from now? Thank you so much for exploring this with us.